Hello. This movie is how to construct parallel and perpendicular lines. And so that's what we're going to do. We're going to do 3 different constructions in this movie. This is from your guided notes. Remember, I always said that we have for constructions the IKEA step-by-step. That's what this is. I'm also got this movie that you are watching on Schoology. So we are going to construct a line parallel to a given line. So the first thing we might be given is a point not on that line. Or if we are not given that, we can always put a point not on that line. And then in order to construct a line parallel, we're going to start with a transversal so that from the transversal, we can construct a parallel line. So the first thing we want to do is to draw a line. I kind of like to put it at a slant rather than trying to make it perpendicular. And that's my transversal that's going to go between my 2 parallel lines cut by transversal. The next thing I want to do is I'm going to construct corresponding angles congruent. And if corresponding angles are congruent, then lines are parallel. So in order to do that, what I need are the 2 angles, both here and here, to be congruent. So I'm basically constructing congruent angles. So we're going to go down here to this vertex where the transversal hits this line. We're going to draw an arc. Then we're going to go up here to the point, and we're going to do a same arc, kind of exaggerating how far around it goes. But I definitely want it to hit where I think that parallel line will go. And the next thing I need to do to construct congruent angles is to measure the opening of this given arc. Then go up here to where the arc crosses the transversal. And then I'm going to create an arc that crosses the given arc. That point where they intersect is the second point on my parallel line. And what I've done here is I've constructed a line parallel to AB because if corresponding angles are congruent, then lines are parallel. It's the converse of the corresponding angles theorem. And that's how you would construct parallel lines. If you are asked to construct a trapezoid, then what you would do is start with a line, construct a parallel line because a trapezoid has 1 pair of parallel sides. And so I'm going to put my transversal, I'm going to put a point where I want my parallel line to go. I'm going to construct congruent angles here and up here. I'm going to measure the opening here at this given arc. And I'm going to go up here, cross over. Where it crosses is my second point. And I get my parallel line. Because converse of corresponding angles theorem. Now I'm halfway there. The last thing I need to do to make this a trapezoid is just to cut it off over here. I can put any kind of line, and it doesn't need to be parallel to this one, perpendicular at any kind of slant, because here, these guys are parallel, and then I've got the other 2 sides cutting it off, creating a trapezoid. So that's how I know it's a trapezoid, 1 set of parallel sides. So that's parallel lines. Now let's look at constructing perpendicular lines. Again, you have the IKEA instructions, and then we're going to go down here. Construct a line perpendicular to AB, and it has to go through C. So for it to go through point C, the very first thing we need are equidistant points on either side of C. So to get equidistant points, we put our compass on C, and then I'm going to put an arc on the right side of C, preserve the distance of my compass, don't open or close it, and put an equivalent arc on the other side of C. This I call the TIE fighter. because if you look at it from Star Wars, these two arcs make it look like a TIE fighter, one of those aircrafts in Star Wars. So by doing that, I've created these new points that are equidistant to C. And then I can Chanel, because Chanel gives us our perpendicular bisector. Keep in mind, when you're Chanelling, you have to be more than halfway. So I'm going to go more than halfway, do a semicircle, preserve the distance, go to the other point and do another semicircle. Where the line crosses both above and below is now my perpendicular line. And it had better go through point C. So I've constructed a line perpendicular to AB, and it's going through C. So this one has a constraint. We were doing perpendicular bisectors with segments, but this one's a little different in that we've got a whole line, and it has to go through C. So we first get equidistant points, the TIE fighter, and then Chanel between the two. And again, you have IKEA notes. Let's move on. We have a perpendicular postulate which says if I've got a given line, a point not on the line, I can construct a line perpendicular to that given line. We're going to use that. Here's your IKEA notes for the next construction. More IKEA notes. And now let's walk through it. Our goal is to construct a line perpendicular to AB, and it has to go through point C. So the very first, and you can't just draw it because then it's not a construction of perpendicular. The first thing we need are equidistant points to point C. We get that by putting our compass on C, opening the compass so that it's more than the distance to the line. It has to be more, because the next thing we're going to do is called a swoop. And I say swoop, there it is. And so we swoop down, creating these 2 points that are now equidistant to C. So instead of the TIE fighter, because that was a point on the line, this one's off the line, so we have to do a swoop. And that creates 2 equidistant points that we would Chanel between. Chanel, we got to open more than halfway. We're going to do semicircle, preserve the distance, semicircle, whoopsies. And then where they intersect above and below, we put our line, and C had better be going through that. It does, and that's how you construct a line perpendicular to a given line through a point not on the line. And that's the end of our constructions. Thank you for watching.